Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring real-world problems which require a quadratic equation to solve. Let's look at example 1. A ball is launched upwards at 48 feet per second from a platform that is 100 feet high. The height of the ball in feet can be modeled using the function h of t equals negative 16t squared plus 48t plus 100. So on the left side, we have a graph. I want you to notice that the starting height of our ball was 100 feet because that's the height it was launched from. Then the ball increased in height to reach a certain height, and then it began its descent, finally hitting the ground here on the x-axis. In part A, they want us to find the maximum height of the ball and label the graph. So the maximum height of the ball would occur right here on the graph. And the maximum height of the ball is just another phrase for the vertex. And we can find the vertex using the formula opposite B divided by 2 times A. So in this problem, our A term is negative 16, our B term is 48, and our C term is 100. So we have opposite something divided by 2 times something. So for B, I'm going to plug in a 48, and for the A, I'm going to plug in a negative 16. Now I'm going to come over here to my calculator. So negative 48, and on the bottom, 2 times negative 16, and that gives us 1.5. Now, that's our x value, so I know it's taking 1.5 seconds to reach the maximum height. To get the actual maximum, though, you're going to have to evaluate this function for the value f of 1.5. So, going to write our function, and I'm going to replace all the variables with parentheses. So negative 16 parentheses squared plus 48 parenthesis plus 100. And then into the parenthesis, I'll plug in our value, x value we're looking for, which is 1.5 seconds. And then I'll use my calculator to evaluate this. So negative 16 parenthesis 1.5 parentheses squared plus 48 parenthesis 1.5 plus 100. And that gives me a maximum height of 136 feet. And it did ask us to label the graph, so now I will label the maximum height is occurring at 136 feet. Now in part B, it wants to know how long will it take for the ball to hit the ground. So according to the picture, it's going to be a little bit more than 4 seconds. So to find it precisely, we're going to use our quadratic formula because we want the height when it hits the ground to be 0. So we're looking at how many seconds will it take to have a height of 0. So I will plug in a 0 for h of t and then write down the rest of my equation. Plus 48t plus 100. And then we can use the quadratic equation to solve this. We actually could probably use completing the square. I just think quadratic formula would be the easiest method to use in this situation. So let's go ahead and plug everything in now. We want the opposite of b, so opposite of 48, plus or minus the square root of b squared, and we know b is 48, squared minus 4 times a, which is negative 16, times c, which is 100, all over 2 times a, which is negative 16. Now, we're going to get 2 answers here because of the plus minus. So I'm going to put this in the calculator, and I'll do the plus answer first. So I made a fraction bar, and then negative 48 plus square root parenthesis 48, parenthesis squared, minus 4, parenthesis negative 16, parenthesis 100. And on the bottom, I'm going to put in 2 times negative 16 is negative 32. All right, so my first time I'm getting, and it said to round to the nearest tenth, is negative 1.4. And then I'm going to get a second answer where I use the minus symbol, and I'm getting 4.4. Now, normally, when we're solving quadratic equations, I'm sure your teacher has asked you to record both answers. But in this real-world situation, all of our answers have to occur in this first quadrant because time is positive and your height, your height is going to be positive also. So in this particular problem, we are disregarding this negative answer and we're only accepting the 4.4. Oh, I forgot to put my units on there. So it takes 4.4 seconds. Now, if I label the graph here, this would be the point 4.4, comma 0. Okay. Let's look at example 2. A golf ball is hit from the ground and travels according to the formula h of t equals 64t minus 16t squared, where h is the height of the ball in feet and t is the time in seconds. So in problem A, they want us to know how long will it take for the ball to reach a height of 20 feet in the air. So in other words, they want h of t to be 20. In the last problem, we were hitting the ground, so we wanted our height to be 0. In this problem, they're wanting the height to be 20. So I'll plug in a 20 for the h of t, and then I'll write down my formula that we were given. Now, in order to solve this, we need it to be in standard form. So I'm going to move the 20 to the other side, and I'm going to rearrange all the terms so they'll be in standard form. So 0 equals, I'm going to put the squared term first, negative 16t squared. Then I'm going to put the linear term, plus 64t, and then I want to subtract 20 from both sides, so minus 20. So now we have it in standard form, and it's easier to figure out our A, our B, and our C. Okay, so we're going to take the opposite of B, so opposite 64, plus or minus the square root of 64 squared minus 4 times negative 16 times negative 20 all over 2 times negative 16. Now, I'm going to use this problem. I've already got the quadratic formula here in my calculator. I'm just going to edit this. So I'm going to put negative 64 plus, change that 48 that I already have in there to 64 squared minus 4 times negative 16. I just need to change the 100 to negative 20. And then I've got a negative 32 on the bottom. So time would be 0.3 seconds. Now let's get our second answer. And 3.7 seconds. Now, are both of these answers valid? And the answer is yes, because as your height of your ball starts at 0, and it's going to reach 20, I'm not sure where 20 feet would be, but let's say it's right there. It's going to reach 20 feet on the way up, and it's going to reach 20 feet on the way down. So let me label that here. This would be 0.3, 20, and this would be 3.7, 20. So the ball has a height of 20 feet 2 different times, at 0.3 seconds and 3.7 seconds. Okay. B, how long will it take the ball to hit the ground? Now in this problem, we're going to only have one answer because it's going to hit the ground right here. It starts from the ground, it goes up, 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 then down, 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 and it's going to hit the ground right here. We want to know something comma 0. We want the height to be 0. So here I'm going to plug in, instead of 20, I will plug in a 0 for the height. So 0 equals 64t minus 16t squared. Now, you don't have to rewrite that if you don't want to, but I would highly recommend you notice that your A is negative 16 and your B is 64 and C is going to be 0 because we don't have a C value. So the opposite of B would be negative 64 plus or minus the square root of 64 squared minus 4 times negative 16 times 0 all over 2 times negative 16. Now let's edit our problem over here. Negative 64 is fine. I'll change that minus to a plus so we can do the plus part first. 64 squared. Oh, I just need to change this negative 20 to a 0. The negative 32 on the bottom. Okay, so we get our time is 0 seconds. Well, we knew that because we knew it was on the ground at 0 seconds. Now let's change the plus to a minus, and we get 4 seconds. Now, in this problem, do not box in both answers, even though they're both positive, because the question was, how long will it take to hit the ground? It can't take 0 seconds to hit the ground. So we know the time that this ball takes to hit the ground is 4 seconds. So I can label this point over here. When the time is 4, the height is 0. Okay. In problem C, they want to know the maximum height of the ball. So the maximum height of the ball is up here. Remember, maximum uses this formula, opposite B over 2A. So this would be negative 64 over 2 times negative 16. So I'm going to make a fraction here. Negative 64 on the top, negative 32 on the bottom. So that's going to be 2. So I know this is going to be 2 comma something. So now we're going to evaluate this function for f of 2. So this would be 64 parenthesis minus 16 parenthesis squared. I'll plug in the 2 seconds. And then we'll evaluate this. 64 parenthesis 2 minus 16 parenthesis 2 parenthesis squared. So that would be 64 feet. So our maximum height of the ball is 64 feet. All right, example 3. The base of a triangle is 7 less than twice its height. If the area of the triangle is 102 centimeters squared, find the dimensions of the triangle. So here we have a height, we'll call h, and the base is 7 less than twice the height. So that would be 2h minus 7. Now, the formula for the area of a triangle is base times height divided by 2. So in this problem, we know the area is 102. And then we have h times 2h minus 7 divided by 2. Now, when we have a fraction, when we're solving an equation with a fraction in it, we want to clear that fraction. So in this problem, the best way to do that would be to multiply both sides by 2. Because if we do that, this 2 will cancel with this 2. All right, so 102 times 2 would be 204. And over here, if the 2's cancel, all we're left with is h, parenthesis, 2h minus 7. So now we have a little bit easier equation to solve. Let's see if we can simplify this a little bit. 204, h times 2h would be 2h squared. and h times the negative 7 would be negative 7h. Now let's put this in standard form by subtracting 204 from both sides. So 2h squared minus 7h minus 204. Now we can solve this equation for h. This is your A, this is your B, and this is your C. All right, so we want opposite B, which would be opposite of negative 7 is positive 7, plus or minus the square root of negative 7 squared minus 4 times A, which is 2, times C, which is negative 204, all over 2 times 2. So let's put this in our calculator now. We want a fraction bar, 7 plus square root, parenthesis, negative 7, parenthesis squared, minus 4, parenthesis, 2, parenthesis, negative 204, close parenthesis. On the bottom, 2 times 2 is 4. All right, so we have h equals 12. Now we need our other solution, so delete the plus and change it to minus, and h equals negative 8.5. Now, let's think about this. Only one of these answers really makes sense for this problem. So ask yourself, can the height of a triangle be negative? And hopefully you said no, so we're going to disregard this problem, or this answer. All right, so we know the height is 12. So I'm going to put a 12 here. We know the base is twice the height, which would be 24, minus 7. 24 minus 7, which is going to give us a base of 17. The only thing we don't know at this time is what is the hypotenuse. What is the hypotenuse? So if I want the hypotenuse, then I'm going to have to use the Pythagorean theorem. A squared plus b squared equals c squared. So I know 12 squared plus 17 squared equals c squared. And then to get c, I would take the square root of both sides. So over here, the square root of 12 squared plus 17 squared is going, and I'm going to round this to the nearest tenth. That would be 20.8. So now we know the dimensions of the triangle. So the height equals 12 centimeters. The base of the triangle equals 17 centimeters. And the hypotenuse is approximately 20.8 centimeters. All right, last example. The dimensions of a square are altered so that one dimension is increased by 7, while the other is decreased by 2. The area of the resulting rectangle is 90 square feet. What are the dimensions of the new rectangle? So let me just draw you a picture of what's happening here. Let me draw a square first. Okay, so in a square, all the dimensions are the same. Okay, they're wanting you to increase one of the dimensions by 7 and decrease the other by 2. So I'll decrease the side and I'll increase the length so that I've formed a new rectangle where this dimensions are x plus 7 because we increased it by 7, and this dimensions are x plus 2. They want to know the dimensions of the new rectangle. Now, the only other thing we know about this new rectangle is that the area is 90 square feet. The area is 90 square feet. And I know the area of a rectangle is length times width. So in this problem, we know the area is 90, and we know the length is x plus 7, and the width is the expression x minus 2. Now we're going to need to do a little simplifying before we can solve this. So I'm going to multiply x plus 7 times x minus 2, and that would give me x squared. Negative 2x plus 7x would be positive 5x, and 7 times negative 2 would be negative 14. Now I still need to put this in standard form, so let's subtract 90 from both sides. This would give me x squared plus 5x, and I want negative 14, subtract 90, and that's going to give me negative 104. So here's your A, your B, and your C, and we want to solve this for x. So we'll take opposite of B, negative 5, plus or minus the square root of B squared, or 5 squared, minus 4 times A, which is 1, times C, which is negative 104, all over 2 times 1. So let's grab our calculator, push the fraction bar, negative 5 plus square root, parenthesis 5, parenthesis squared, minus 4, parenthesis 1, parenthesis negative 104. On the bottom, 2 times 1 is 2, so that would be 8. Let's get our other answer by changing that plus to a minus, and that would be negative 13. Well, we cannot have a height that's negative, so we're going to use the 8 as our value of x. So here's what we know, x is equal to 8. And so to figure out the, let me draw this a little bigger. To figure out the dimensions of our rectangle, we need to take 8 minus 2 and then 8 plus 7. So here the length would be 15, and 8 minus 2, the height would be 6. So the dimensions of our rectangle are 6 by 15 feet. And that concludes today's lesson on quadratic applications.